Hi, it's me again. We are going to talk about the addition and subtraction of radicals still, but we are going to add now and variables in the radicands for us to apply the laws of radicals we learned in the previous videos. Still, remember, please be reminded that if we're going to add or subtract radicals, we need to look at similarity or likeness of radicals. We have two different considerations. Number one, they must have the same indices. And number two, they must have the same radicands. For items with the same indices but do not have the same radicands, we can apply any of the laws of radicals to simplify it further and see if we can operate them already. I'm going to share to you a practice exercise B for addition and subtraction of radicals, now involving variables. So for number one, we have here the item or the given square root of 4x minus square root of x. These two give the radical expressions in the given have the same index. We have index is 2 because both of them are square roots. But at first glance, we don't have the same radicands. In short, we cannot just simply subtract these two radical expressions immediately. But we can actually simplify square root of 4x here. Square root of 4x using multiplication law can be rewritten as square root of 4 times square root of x. And let's just simply copy the other side or the other term because we cannot simplify it further. Now that we have square root of 4 is 2 square root of x minus square root of x. This 2 here is already an integer or a numerical figure here. It's not an index. So do not take this as an index. The index here is still 2 for the square root. Now that we have the same radical expression, square root of x and square root of x, we can operate now the numerical figures outside the radical expressions. 2 minus 1. Again, we have here a 1 value for this radical expression. In short, the answer shall be 2 minus 1, 1. And then you copy the radical expression square root of x. No need to add or subtract the radicands, only the numerical coefficients outside the radical expressions. This could be further simplified to a better expression, which is the simply square root of x, because this understandably has 1 as a value outside the radical expression. See, we still use the same processes. It's just that we just added a variable in our radicands. Proceeding to number 2, we have square root of 3a squared minus a square root of 18. Right? So we cannot add them immediately, but we can simplify both of them because both of them will cover um, multiplication laws. So let us try to simplify them one by one. For some of you who could simplify both of them at one time, it's okay with me, no problem with that. But for some of us who are still in still in confusion on what to do, we are going to do it step by step. Let's try to simplify this first. This can be rewritten as square root of 3 times square root of a squared. Since this is already a squared and it's a perfect square, so this could be simplified further as square root of 3 and then a. Okay. Or we could rewrite this using commutative property multiplication as just simply a square root of 3. Any of the two will stand. Okay. Why do I write this in this form? Because in the second form, we have a square root of 18. So it should just be similar so that we could, in adding later on, we will not have any problem. Okay. So the second one will be equal to a square root of 9 times 2. because 18 is 9 times 2. So we have here a square root of 9 square root of 2. Square root of 9 is 3. So you have 3 times a square root of 2. So we have simplified the given for number 2. Now let's try to see if we can combine them. So instead of 3a square root of 3a squared, you have a square root of 3 to be subtracted by 3a square root of 2. Okay. Some of you might say the answer, sir, is negative 2a because we can operate a here minus 3a. But again, you need to determine whether the radical expressions have the same radicand. Here you have 3, this is 2, therefore they are unlike radical expressions. We cannot simplify them further. This shall be our final answer. So as to why do we not stick with this? Because this is the simplified answer. Okay, let's proceed to number 3. Number 3 is 2y square root of 8 minus 5y square root of 32. So again, let's simplify them one by one so that there would be no problems later on. You have 2y square root of 8 is 4 times 2. So this is actually, again, we are separating the two of them so that there would be no, what do you call that, misconceptions as to where should I look first, where should I look next. Let's focus on one term per time. So this is 2y square root of 4 times square root of 2. And square root of 4 is 2. So that's 2y times 2 times square root of 2. So 2y times 2, that's 4y square root of 2. That is for your first term. As for your second term, again, we are not yet combining them. You have 5y, and square root of 32 can be rewritten as square root of 16 times 2 because 16 is a perfect square. You may want to start with, how about, sir, 4 times 8? You may do that. But once you look at 8 as part of 4 times 8, 8 can still be simplified as 4 times 2. So that's another step. But I would choose here 16. So you have 5y square root of 16 and a square root of 2. Square root of 16 is 4 times square root of 2. Multiplying the three items here, you have 20y square root of 2. Now that the two terms are already simplified, let's not try to combine them if we can. Instead of this given, you will have 4y square root of 2 minus 20y square root of 2. Unlike in number 2, wherein as you simplified the expressions still, the radical expressions are still unlike. In number 3, it's now very obvious that they are like terms. So what we could do is operate the terms outside. 4y minus 20y. That is actually equal to 16y, and then copy the radical expression square root of 2. So this is the final answer for number 3, 16y square root of 2. Let's proceed to number 4. Number 4 is now on the realm of cube roots. So you're going to look for the perfect cube factors. Okay? So you have here cube root of 3y to the power of 4. Okay? And then plus 2y cube root of 3y. Take note that this is an index, not a power of y here. So not be confused with that. So in number 4, this is already in a simplified form because 3y 3 is not a perfect cube, y is not a perfect cube, therefore this is already in its simplified form. But for the first term, we can simplify y to the power of 4 here because we can rewrite this as cube root of 3 times y cube times y because y cube is a perfect cube. So we have it here, cube root of 3 cube root of y cube and then cube root of y. Then we have, this can be simplified, this cannot be. So you have cube root of 3, that's y, and then cube root of y. And since these two terms cannot be simplified, we just simply combine them into one using the reverse of multiplication law. So this is equal to y cube root of 3y. Okay, this is the simplified form of the first term, and let's combine it with the second term, which is already in a simplified form. That's y cube root of 3y plus 2y cube root of 3y. Take a look at the radicands and the indices. You have 3, 3, same index, 3y, 3y, same radicand. Therefore, let's operate the items outside. Y plus 2y. The answer is 3y. And copy the radical expression cube root of 3y. So this is the final answer for number 4. Again, number 4 is different from numbers 1, 2, and 3 because number 4 is now in cube roots. Let's have number 5 as your last item. Let's copy it here. Cube root of 16 b to the power of 4 plus 2b square root of 2b minus b square root of 8b minus cube root of 2b. Do not be confused as to the length and the um, complications or the complex combination of terms because you just need to simply look at them one by one. Let's look at them one by one. So for the first term, 16 and cube root ito. So 16 is a product of 8 times 2 wherein 8 is a perfect cube. So this can be written as 8 times 2. And then b to the power of 4, same as the number for example here, can be written as b cubed times b, so that we could actually simplify b cubed here. So this can be written as cube root of 8, cube root of 2, cube root of b cubed, and then cube root of b. And we can simplify this because 8 is a perfect cube and b cube because it's a perfect cube. So cube root of 8 is 2. Then this is already, sorry, that's still green. I forgot. This is 2. And then as is. And then you have b. And then as is. Okay. And then multiply 2 and b and then use the multiplication law for the other terms. That's already in simplified form. You have 2b and then cube root of 2b. Okay, 2b cube root of 2b. Next, this is already the second term. This is already in simplified form because 2 is not a perfect square and b is not a perfect square that can be simplified by the square root. So as is. Next, this you have square root, sorry, you have square root of 8b, and 8 is a perfect, it has a factor which of has a perfect square factor in the form of 4. So this can be simplified. So simplifying this, you have b square root of 4 times 2 times b. And then you have b square root of 4. And since both of them can be simplified, let's just simply write square root of 2b. And the square root of 4 is 2. So you have 2b square root of 2b. Okay. So we have plenty of 2b's here. Do not worry. Look at them one by one. The last term is already a simplified form as for the cube root is concerned because 2 and b are uh, both of them are not perfect cube numbers. So let's combine them into one. So we will use this 2b cube root of 2b, okay? And then we have here plus 2b square root of 2b minus the value of this, which is 2b square root of 2b. And finally, you have minus cube root of 2b. Okay, so we can only combine those which can be combined. Again, they may look like they have the same radicands, but look at the indices. Okay, so let's use proper coloring here. What we can combine is the first term, cube root of 2b, and the last term. And we can also combine the second as square root of 2b and this. So this would become, let's start with the first two. You have 2b cube root of 2b minus cube root of 2b. Okay. And then the second and the third will just be equal to 1 because 2b minus 2b, sorry, equal to 0 rather, because 2b minus 2b is 0. 0 times 2b will have 0. Okay? So 0, the value of that will be 0. One misconception for now for this here is your answer, my answer, sir, is 2b because I removed this and that. That's wrong. That's incorrect. Okay? We cannot remove that because what we are following, just like when we say simply in example, a simple example in algebraic expression, let's say 3x minus x. We do not say the answer is 3 because I remove, sir, x and x. That's why you have the answer, which is 3. Right? Take note, that's incorrect in our simple algebraic form. That is also incorrect here. So what we could actually do here is to factor out cube root of 2. This is, by the way, this is for me, I will accept this. This is already acceptable. Okay? But you could write it better by factoring the cube root of 2b. So you will have here cube root of 2b, and you have the quantity of 2b minus 1 because we have here 1. You factor these two out and you will have 2b minus 1. But of course, again, if you are in confused with this, because it will add another uh, common concept in algebra, I would be okay with this. But this is better. Okay. This is the last practice exercise for addition and subtraction of radicals. Again, what you need to remember is the concept that you can only add or subtract radicals with uh, same indices and same radicands. If both of them doesn't have the same index and radicand, stay as it is as long as you simplify them further. Hopefully you've learned from this video and use this video as you study more on addition and subtraction of radicals. In the next video, we will talk about multiplication of radicals. See you there. Goodbye.